Awesome. So, hello everyone, and welcome to this stream on Opni. And very excited to have you all. It's Monday, but it's a learning Monday, so it's not a boring Monday. So we'll make sure we learn something new today, and this is really very interesting project. I'm really excited about this, and hope you are too. This is something which is, completely new in a different domain, in a AI kind of AI machine learning domain, which we have never talked much about. And this is kind of a different project with respect to what Rancher has been doing. So really excited for this one. And welcome everyone to my channel. If you are new, my name is Sayam Pathak. I'm a CNCF ambassador and director of technical evangelism working at CIVO. And I do live streams on different cloud native technologies, new open source projects with awesome people like we have today, Sanjay. And we explore technology, we do demos, deep dives, and we try to take questions from the community so that you people understand what it actually is, what its future, how you people can get involved and accelerate in the development of the project. So I see so many awesome people joining. So hi Ayush, and Adrian has joined. So hello Adrian, which is very good. We all learn from Adrian how to do cool live streams. So yeah, welcome you all. If you're new to the channel, make sure you subscribe it. That gives me motivation to do more. If you are following, seeing on Twitch, then make sure to follow that. And yes, there will be swag giveaway in the end of the stream. So let me pull out the link for you. So I'm pasting the link in the chat. Make sure you fill that link because it is like, if you fill that, then only you'll be entered in the swag giveaway. In the end, we'll do around 5 swag giveaways. So yeah, now we are done with the introductions, but let's introduce our guests. So we have Sanjay today with us. He's on the Opni team and behind the development of the project, working at SUSE. So welcome Sanjay to the stream. Really thank you for giving your time on Monday for doing this. So please introduce yourself to the community.
Thanks, I am excited to be here. I'm Sanjay Nadhavajhala, lead for the Opni project. My background is in machine learning and AI, really excited to talk about Opni and how you all can start using Opni. So,
awesome.
Should we dive into the slides?
Yeah, you can share the slides meanwhile. So basically we'll be discussing all about Opni. Of course we'll do that, and the first thing would be like the motivation, because this is something very new and a different kind of concept. So let's talk about the motivation first, like why this came into existence. What was the thought process and challenges that were there? What problems you saw in the ecosystem, and what is Opni then trying to solve that?
Sure. So Opni is AIOps for Kubernetes plus observability. And before I get into the motivation, I just want to introduce the team because I think the consistency of the team and the composition of it is really important for what we're trying to solve. So we have a bunch of different variety of experiences on the team. So we have 3 machine learning AI background. We have Kubernetes experts. Craig was co-founder of Rancher. We have people that are real experts in Kubernetes as well as experts in AI and machine learning. And so we got together for this Opni project, which is kind of a combination of the Kubernetes world with cutting edge of AI. And so the agenda for today is motivation, what is Opni, we'll have a demo, and then I'll share the roadmap, and finally how you all can get involved and start playing around with Opni. So the motivation for Opni really started off with the role of an SRE or an operator that is managing Kubernetes clusters. So put yourself in the shoes of a IT ops professional. You probably use a variety of different tools. Some of them are probably on the screen that I'm sharing right now. And all these different tools help you accomplish something, and there's a plethora of them, and all of them bring something to the table. And so generally, IT teams are growing in size and are growing in size and are using more and more tools to aid with monitoring, automation, collaboration. But as the number of tools grow, IT ops professionals are being flooded with too many incidents, tickets, and notifications. This is because more and more monitoring tools are being adopted and used, again, because each one brings its own unique advantage. But more tools doesn't necessarily mean more productivity. It does mean that there will be more false positive signals that are coming in about potential incidents and threats, but less clarity about where to look and what to look at in the case of an outage. Timely outage detection, investigation, and resolution remain a challenge, and that's where we see potential for AI and machine learning to disrupt the market and the status quo. So really, the problem that we see is that we have all these different tools, observability tools. They're all producing a ton of different data, and right now it requires humans to manually set thresholds, filters, and other things. It requires human intervention to even leverage some of these tools to their full capability. So we want to apply AI to some of these tools to get basically help SREs, help IT professionals out while managing their Kubernetes clusters. So additional motivation is that there is no existing open source AIOps for Kubernetes. AIOps, if you are not familiar, it's the application of AI and machine learning to IT operations. We also believe that the next gen of observability tools is not only going to be displaying signals in a nice looking dashboard, but rather there's going to be AI and ML involved, and it's going to tell you which of those signals is most important to you, because depending on what workloads you're running, some signals will be more important than others. So we really believe that next gen observability is going to include AI and machine learning. And so that's what we're hoping to build out with the Opni project. And also, naturally, Rancher helps users manage Kubernetes clusters. Rancher comes with diagnostic tools, monitoring, alerting. There's Rancher monitoring that installs Prometheus for you, and you can see metrics, insights into your cluster. There's also Rancher logging. So we just thought that it would be a natural fit to start introducing next-gen observability with Opni. So, any questions so far?
No, but I think, yeah, that's really a great start. So basically we have the observability tools and we are monitoring the data and we are getting the metrics, but it's us who is setting the kind of alerting mechanism, who is setting the thresholds when the alerts will come, and different tools for that as well. So yeah, really interested to know how Opni will be using that sort of data and streamlining it, and then setting the right set of alerts on its own. So and that's where I can think of like AI ops is obviously it's intelligent enough to do these things which are done by humans or which are done by the SREs at the moment. So it will eliminate that, not completely, but it will start to eliminate that and learn over the period of time, and would take good decisions based on the metrics that have been gathered by different set of tools. And yeah, also a very good point mentioned by you is the Rancher integration. So Rancher comes pre-built with you can just enable the monitoring, and it spins up your whole Prometheus stack, and you can gather all the metrics. So it would be interesting how those metrics are taken and which set of alerts are getting generated based on the set of experience, data sets, and all that.
Yep. And so I know I mentioned metrics and Prometheus, but we actually saw the initial entry to the AI ops world that makes most sense for us is by diving into logs. and log monitoring. Because for metrics, and I'll discuss this in our roadmap, because metrics and metric anomaly detection is going to be a part of our V0.2 release that will come out later this year. But we initially developed our POC, and our first release is for log anomaly detection and for log monitoring. And so the reason why we decided to go with logs first is, like, people use popular log management tools such as Datadog, Splunk, or the Elastic Stack, and there's many others, right? And people use this today to store their logs, compliance, as well as, like, in the case of in the scenario where there's an outage, they would go to these log monitoring tools to start trying, like, investigating. Are there any signals within my logs that indicate, like, what the root cause is, and things like that. And so, yeah, the reason to use these tools, you would search for error logs when an outage or an incident occurs. But what's lacking is, in a sea of logs, where do you start looking when an incident does occur? Grepping for an error in your log management console is insufficient, which is why operators typically rely on tools like Prometheus and Grafana to or the Datadog dashboard, which is really good for that stuff too. You typically rely on metrics to tell you where to look, because you're relying on greps, you're relying on filters that are too basic, and you can't really rely on the logging level either. So basically, you can't automatically find anomalous logs. And nowadays, there are tools like ElasticML and other. I think OpenDistro for Elastic, which is maintained by AWS, they have an anomaly detection tool. But even to use tools like that, you need to have, like, some prerequisite data science knowledge to even help you get started. Because at the end of the day, you have to build those models yourself. And that's what a lot of AI ops tools for log monitoring come with. So we decided that there's got to be an easier way to help you leverage your logs, because your logs are extremely rich data about what's going on in your cluster. Typically, the metrics that come out in Prometheus are a lagging indicator, and your logs are going to tell you a whole bunch of your story before your metrics do. So we decided to go into log monitoring initially, and yeah, that's what I'm going to be talking a little bit more about today. So
just
Opni,
before you touch, like, will you be touching on from basically what are logging agents you can pull log from? I mean, what are logs you can do? Like, we have log aggregators, we have Loki that can streamline some logs. So can we use Opni there also, or is it limited to a certain set of logging?
So no, your Kubernetes cluster emits logs, right? And you can use things like Loki, which is a Grafana Labs tool. Loki is like the equivalent of Elasticsearch. It's a logs database, right? And so you can ship logs to Loki or Elasticsearch using different logging tools like Fluentd, Fluentbit, etc. There's a ton of them. But our goal is to basically we don't want you as the end user to worry about any of that. We're expecting that you're going to continue using your Datadog or Splunk for your long-term log storage. But what we want people to use Opni for is similar to how people are using Prometheus right now. You install Prometheus onto your clusters that are important to you, and you start getting these rich metrics, right? So similarly, we want you to install Opni to every cluster that you think is important to you, ideally probably has business value to you. And so similarly, Opni is going to come with a bunch of different things. Initially, Opni is going to come with Elasticsearch and Kibana installed with it. And so this is where you can start exploring logs for yourself. So let me go through the next few slides. I think things will start making a little bit more sense.
Cool.
So Opni is AIOps for Kubernetes plus observability. Like I mentioned before, initially we're tackling logging, and then after that we're going to add AI to other fields as well. And the goal is to reduce mean time to detection and mean time to resolution. So what does Opni give you? Opni will give you AI-generated insights into your cluster's log messages. So specifically, we've divided it into two categories: the control plane, etcd, as well as the workloads and applications that you're running in your Kubernetes cluster. So Opni comes with OpenDistro for Elasticsearch and Kibana. OpenDistro for Elasticsearch is the ES that is maintained by AWS. Elastic, the company, they recently changed their licensing for Elasticsearch, so you can't really use that anymore. But OpenDistro comes with a whole bunch of other security tools, which are really nice, because let's say you don't want to install Opni into your cluster that you want to monitor, and you want to install Opni as its own dedicated cluster, and you want to ship logs over. It opens the door for a bunch of different things, and we'll discuss that a little bit later. What are the different user scenarios? So Opni, when you install it, it comes with two things: the Opni Insights as well as Elasticsearch and Kibana. Basically a short-term logging solution. It's not meant to be a long-term logging solution like your Splunk, like your Datadog. But this data is supposed to exist within your cluster that you are monitoring for up to 7 days, or the limit that you set for like how much memory you want to dedicate for Opni, whichever comes first. So Opni initially, log anomaly detection. It's going to classify every single log message as either normal, suspicious, or anomalous. And so this will immediately help operators with the problem of what logs they should start looking at when investigating an incident. Reducing the scope of log messages from, say, 100,000 logs in the last 10 minutes down to just maybe, say, 5,000 logs significantly improves mean time to detection. Because, again, most of the time, the reason why people don't look at logs before they look at metrics is because there's typically a ton of them, and you don't know which logs to look at initially. And so the Opni is going to reduce the scope of which logs you should look at, and that's just by tagging which logs are suspicious and anomalous. And within Kibana, we have a custom-built Opni dashboard that we'll see in our demo. And so so Opni allows the operator to consume log insights as metrics, thus allowing them to set downstream alerts when Opni is raising a lot of logs as either suspicious or anomalous. So Opni comes with one pre-trained model that focuses on control plane and etcd logs. This model will be maintained by Rancher Labs and is currently focused on RKE1, RKE2, K3S, and vanilla Kubernetes distributions. More distributions in the upcoming weeks will start to be supported for our pre-trained model that will be maintained by us. So unfortunately for cloud providers that offer managed Kubernetes, like EKS or GKE, the control plane is sort of abstracted away from you. So this pre-trained model is not going to be it's not going to be useful if you're running your workloads on those types of clusters. If you install Opni onto those types of clusters, you won't be able to leverage our pre-trained model, but that doesn't mean Opni is not going to be useful to you, because the pre-trained model is just half of the story. The other half of the story is we have additional models, machine learning, deep learning models that focus on your workload and application logs. And so these models will automatically learn and adapt to your system's steady state over time. And so what this means is these models are trying to understand what constitutes a normal environment in your workloads, in your Kubernetes cluster. And once it starts understanding what is normal, then it will start understanding what is not normal. So basically, what is suspicious or anomalous behavior that's going on within your cluster. So from a high level, from an AI modeling standpoint, that's how we've approached this problem. And typically in any sort of any anomaly detection, you try to model what is normal. And when stuff outside of the normal appears, that is considered abnormal, right? And so these additional models that will learn your workloads and application logs, it's for any Kubernetes cluster. And this requires, for our v0.1 release right now, it requires that you have 2 GPUs to leverage this feature. We're going to reduce that down to 1 GPU in a few weeks. And so with just 1 GPU attached, you're going to be able to leverage some deep learning, all the AI stuff that comes with it. So that is one thing to keep in mind. To use Opni, you're going to have to, if you want this workload application logs AI insights feature, which is what we anticipate a lot of people are going to want, you're going to have a GPU attached to your Kubernetes cluster. Any questions before I move on? I know I just said a lot of stuff.
No questions as such, but yeah, this sounds really interesting, like how this pre-trained model. So this pre-trained model is available for everyone to have a look, or is it only?
Yes.
I mean, okay, cool.
Yeah. So by default, if you're using an RK1, RK2, RK3S cluster, then you're going to have a pre-trained model that comes installed with Opni. And the nice thing about this pre-trained model is because it's maintained by us, it's going to constantly be updated and improved. And yeah, so again, as you don't need to worry about Kubernetes distributions, if like a distribution changes some logging format or introduces new sets of logs or removes logs, our pre-trained model is going to be constantly iterated on and improved. So yeah. Okay, so I'm sure some of you have come across some existing AIOps tools, and I'm going to point out some of the differentiating factors between Opni and them. So as you all know, SUSE, Rancher really focused on Kubernetes, right? Most of the audience today are probably Kubernetes operators, and you may not have built your own AI models before. And frankly speaking, in the SRE world, you probably don't care what the AI models are, and you definitely do not want to be building these AI models yourself, right? So the biggest differentiating factor between Opni and a lot of the competition is that the operator does not need any knowledge of AI or machine learning. Our models automatically kick off themselves. Initial training and retraining down the road, again, it's all self-managed. And so you as the operator don't really need to understand the model or really interact with it all that much. It's a single command install and really easy to use. So we've built this CLI named Opni CTL, and it's a guided install. It will ask you a bunch of different questions, and it will basically, I think somewhere down this deck, I have a user scenarios. And so as a user, you might have your environment be set up with a bunch of different configurations. So Opni CTL is going to help you install Opni very easily. Opni does not require a high volume of logs to get started. As I mentioned, we come with a pre-trained model, and Rancher Labs is filled with experts in Kubernetes, and we are going to be leveraging our expertise in Kubernetes to help build this pre-trained model that we will maintain. The AI models automatically adapt and learn from changes in your cluster. So let's say you're using your Kubernetes cluster for a variety of different workloads that you kick off at different times of the day or different times of the month, year, etc. Our AI models are going to automatically adapt and learn and remember everything that's going on. Also, if you're worried about compliance, since you're installing Opni onto the cluster that you're monitoring, the data, your log data, and in the future, metric, event, trace data, none of that is actually going to leave your cluster. None of that data reaches Rancher Labs or hits any other endpoint. So you can be safe from any compliance issues. As I mentioned, comes with a specialized out-of-the-box model that's focused on Kubernetes control plane. It does not rely on connectors to external observability tools. It's a real-time streaming solution that comes with Elasticsearch and Kibana with it. And lastly, it's open source. So everyone is going to have a say. If any of you guys have suggestions or features that you'd like, we want to interact with all of you, as well as if you would like to get involved from a development point of view, then we're happy with that as well. So those are all the differentiators, why you would use Opni over any of the other paid services. But yeah, any questions?
I think everything is clear.
Okay, cool. So we'll jump into a demo and revisit these slides in just a second.
Yeah, I think demo will make things more clearer, how it actually works in action, and how the anomaly detection is happening with the logs that is getting captured with the pre-trained model for control plane and etcd. So when you one question I have, like you talked, the pre-trained model works for K3s as well. So it's for K3s etcd, or the K3s SQLite one also is part of the pre-trained model?
I think it's only for etcd, but K3s we just introduced last week. We're still iterating on that. So it's really going to, the pre-trained model, we're going to have it cover like all scenarios. It's not like if you're using K3s, it downloads a model for K3s. This is one all-in-one model. It's going to cover all different types of environments. And so it is a deep learning model, right? And that's kind of like the advantage with deep learning. You can have all your data be in like a mosh pit, and it will learn the semantic meaning behind the data rather than specializing in one domain.
Interesting. And there's a question like, which neural network architecture is being used by Opni, and what data set is being used to train the model?
So the data set that's being used to train the model, we're generating our own training data for all these different Kubernetes distributions that I've mentioned. And so we have normal workloads that are running on these Kubernetes clusters. So we train off that. We understand what is normal control plane etcd behavior. And so since we all have that information, we're able to train like customized models, which we ensemble together and package together as one pre-trained model. In terms of like what models we're using, I have a slide that's dedicated to that. We'll get to that in just a sec, like after the demo.
Cool.
Okay. So let me share my screen again. So cool. All right. So this is the Kibana dashboard. I mentioned that Opni comes with Open Distro for Elasticsearch, as well as Kibana. And so if you are a Kubernetes operator and you're using a log management solution, when you log into that tool, it probably looks something similar to this. In the last 15 minutes, the cluster that I've set up, by the way, just to add some context, I have a 3-node etcd control plane and 3 worker nodes, right? And that's my Kubernetes cluster setup right now. I am running this very popular sock shop application. I'm sure most of you have come across it in your benchmarking or testing. So I am generating load to this sock shop application, and that's generating a ton of these logs, right? So in the last 15 minutes, there's 51,000 log messages that have entered the system. And so I've already pre-set up the environment, but later, towards the end of the demo, I'll show you all how to set up your own demo environment with just one command. And that takes several minutes for it to get set up, which is why I did it beforehand. But let's say you are an operator, and given the status quo, if you're using your own log management solution, you're probably going to come into a dashboard that looks something similar to this. And again, you see 51,000 log messages. You're not going to look through all of them. You can grep for something like an error and see if anything pops up. And there's 243 errors. If we start taking a look at some of these log messages, it looks like they're probably unrelated to an error, actually. It just looks like a bunch of log entries for some sock shop orders that are coming in. So really, by just looking at the logs, you have no idea what's actually going on in your system, which is why everyone falls back onto metrics because metrics tell generally a better picture. But these log messages, if you take a look at it, like these log messages are so granular, they give so much rich information that right now they're not being leveraged at all. And so what we have with Opni is, again, we have a control plane, etcd model, as well as workload models, or the workload model, which is learning data, log data that's flowing in of applications that are running in your Kubernetes cluster, right? And so with Opni, we want you to have a bird's eye view into what's going on to your cluster using logs, in the future metrics, traces, events. So initially for logs, we want you to see, basically be able to quantify the types of log messages that are coming into your system at any given moment without you having to set up these log filters. So what we have here is 4 different panels. We have Opni Insights at the top left. We have an anomaly panel at the top right. etcd control plane, workload logs. The bottom 2 panels they're going to be populated with log messages that the models are going to mark as either suspicious or anomalous, and those are the logs that you should focus on. So right now the system is in a steady state. There's nothing gone wrong with the system. So what I'm going to do is I'm going to inject an error. So for this node right here, I'm going to take down etcd, and actually within this Rancher server dashboard, eventually you'll see that there's something wrong with etcd on this node, and we'll hopefully see that over the course of this demo. But what I'm going to do is I'm going to log into that node, and I'm going to take down etcd. And this might seem like a very trivial failure to inject, but it's a very common one. For example, if there's something going on with the network on a particular node, of course, Kubernetes is built to be robust and kind of abstract away from these types of errors. But the point is, like, you as an operator want to be aware of all sorts of errors, even if if it's not like a business impacting error. So let me take down etcd. Okay. So I've stopped etcd within our Kubernetes cluster, and I'm going to go back to our dashboard, hit refresh, and we see that this etcd and control plane logs to investigate panel starts being populated. And we start seeing a bunch of different logs appear. And so if you are an operator, what you would do with Opni Insights is you would probably set thresholds for how many anomalies are coming in, how many suspicious logs are coming in. And so what we're also developing is like an automated tool, basically a model that will kind of help balance out how many alerts you want to be notified on. So that's an upcoming feature. But right now, if you as an operator can set a threshold, if the number of control plane logs breaches some threshold, send me an alert on Slack or via email, right? So Open Distro Elasticsearch comes with that feature. But I just injected this error, right? We took down etcd. If we go back to the Rancher server dashboard, we see that nothing has really happened. Like, the server hasn't communicated that something's gone wrong with etcd. And eventually, maybe like 10 minutes, something like that, from my experience, and like in some amount of time, eventually it's going to go from active to like a warning, and it will say like etcd is unstable or something like that. But the point is, Opni was able to catch it immediately. And you as an operator, what you would have to do is, since it's populated a ton of these logs, again, 50,000 logs in the last 15 minutes, we've isolated down to 2,900. What you would do is you would maximize this panel and start investigating these logs as you would if you set up previous filters. Again, the problem with filters that I didn't mention is to create filters, usually SREs do this when they've seen a ton of errors that are constantly repeating, and they want to be able to catch these errors. And so typically filters are not good at catching new types of errors that are introduced into your system. And so again, that's another advantage of using Opni. So these errors, it makes it very clear that there is an etcd issue, right? It's saying that it's unable to reach this this IP. If we take a look at this IP, and I'm sure a lot of you can figure this out, we see that this internal IP belongs to this node, and so immediately we know something problematic with etcd on this node is going on, and it's really easy. Mean time to detection, mean time to resolution. We've minimized that, right? And so that's kind of like why we want people to use Opni. The Opni dashboard comes pre-installed. So I'm going to also quickly demonstrate a workload log. So I've had this cluster up and running for the last 12 hours. I mentioned that the sock shop, I was generating like a load of I was simulating 3 users basically, and I was generating a load. And so in the last 12 hours, Opni has learned what is steady state and has trained a model for itself. And so I'm going to inject a database failure. I'm basically going to fill up a MongoDB, which SockShop is using for keeping track of what orders there are. So I'm just going to fill that up, and what that's going to do is it's going to generate some exceptions, and we should start seeing that in the workload logs. So let me do that. I can take any questions as this is happening. This might take some time to fill up that database.
Yeah, there are a couple the system requirements for running Opni.
Yeah, so the system requirements, you need an additional 32 gig of RAM, 2 GPUs for now. Again, we're optimizing it so that way you only need 1 GPU, as well as at least 8 CPUs, 8 virtual CPUs attached to the cluster.
Okay, and yeah, that was the same follow-up, are GPU nodes needed for Opni as a requirement?
If you want to leverage the workload logs, if you want Opni to understand what your logs are and start giving insights on your logs, then yes, you need a GPU. If you only want to leverage etcd and control plane, you don't need a GPU. So etcd control plane is the pre-trained model. If you only want those insights, you don't need to attach a GPU, and you can start consuming those insights.
Cool. And also, in meanwhile, for those who have just recently joined, but there is a swag giveaway form that you can fill, so that in the end we'll just do the swag giveaway. So make sure you fill the form. I'm just reposting the link once again.
So when I set up StockShop, actually, I did not give a limit to the size of the database, which I usually do for demos. So what I'm going to do instead is just go ahead and delete that database altogether, and that's going to start raising a ton of errors for services that rely on it. Okay, so let me quickly share this so you guys have an understanding of what I'm doing. So previously I was running a script that's going to overfill a MongoDB, the MongoDB for the orders database, which keeps track of SockShop orders. Again, the cluster is quite large, and I did not set a upper limit to the database, so it was taking quite some time. Actually, it just finished injecting that, so disregard everything I've said in the last 30 seconds. So I'm going to refresh the page, and we're going to start seeing Okay, so it did not pick up any anomalies just yet. Okay, anyway, the anomalies that you're going to try in the demo, you'll be able to replicate this. For the sake of time, I'm going to continue with our talk. But basically, once you start playing around in your own environment and you have a GPU attached, go ahead and start like filling up databases. If you install StockShop, or if you're running on your own applications, start trying to break your application. You'll see that Opni is going to be able to catch logs that are in your workloads. And if you're more interested in this, on the Opni.io page, I gave another presentation, and in that we go through the same exact example. So with that, I'm going to go back to our slides. So someone asked earlier, what kind of like deep learning model are we using, right? And so Opni Technology, in terms of the AI machine learning, deep learning space, is we have two main models that are running. One is called Drain. It's a machine learning method. Both of them are based off of public papers that were submitted. Drain is a very popular log parsing algorithm. It learns log templates from incoming log messages. We've adapted it to also be an anomaly detector, where, I mentioned before that there are filters that are set by users. So we started leveraging Drain to automatically create filters for itself, and basically be able to identify logs based off the anomalous and suspicious logs based off these filters. Because Drain is learning log templates from log messages, it's able to detect changes in the environment. And Drain is actually what controls the initial training and retraining of our deep learning models. And our deep learning models, we based it off this paper called NuLog, and we've actually heavily adapted that. And so this is a deep learning method. It requires a GPU. If you guys are familiar with LSTMs or things like that, it's basically a sequence-to-sequence based model. It learns semantic contextual information from the log messages. It is very accurate, but it requires kind of a large amount of data / a steady state to work really well. But the nice part is, like, the way that we've designed Drain is that it only kicks off training once we have reached a steady state, and basically Drain is the manager for our deep learning algorithms. And yeah, so our deep learning algorithms very accurate, and they're able to handle large amounts of data, and their predictions are very robust. So you can train on like one domain, and you'll be able to inference on another domain, and the predictions will actually be pretty good, because again, that's because it's learning the semantic meaning behind the logs. And so yeah, if you're more interested, I can definitely maybe come back and give a further talk on like the deep learning methods, more granular details. But I'm not sure if the audience is too interested in that for today's session. So,
yeah, definitely we should have another session focused completely on the deep learning models that are used, how people can get only specific to involved with those research things and all that. So that would be definitely a worth session, the next time we do that. But
yeah.
It really sounds interesting, the Drain and NuLog. So would be really interesting to see that in more deep dive later on.
Yeah, definitely. And so I mentioned right now for initial v0.1 release that we're requiring 2 GPUs, right? And so the reason for that is, like, there needs to be a GPU on standby for training. There needs to be a GPU for your inferencing. And so we're developing like a GPU management tool, which will basically be able to handle both training and inferencing. And it's going to be able to share one GPU. And we're also experimenting with a third model, which is going to mimic our deep learning model. So our deep learning model, in a nutshell, what it's doing is it's going to take a look at a log message, right? And it's going to take each token in a log message and try to understand if the tokens around a particular token make sense. So does the semantic meaning behind all the tokens and the neighbors that are around these tokens, does it make sense? Does it satisfy what we've observed in previously observed steady states? And so we've kind of taken this approach and tried to put it into a machine learning model, because ML models, you can get by running on the CPU. You can also start training on the CPU. And so we know for a lot of these Kubernetes clusters, operators don't necessarily have the budget or time to set up a GPU. So we're experimenting with a third model, which mimics our deep learning model. Obviously, it's not going to be as good because deep learning is like state of the art. But we understand that is something that users would want, a model that does not require a GPU. So we are experimenting with a third model as well. We also have plans of creating a open source model hub in which people can share their Opni trained models for common workloads and environments. That's something we have scheduled down the line. And so, yeah, we plan on introducing this for both control plane as well as workloads. So let's say maybe you're running like Baidu's like deep speech for speech to text processing, right? Then a lot of people are running this on Kubernetes because there's like a Kubeflow version of it. And so let's say you want a model, you've already trained a model for that and you want to share it with everyone. What we want to be able to do is start allowing for that. So that's, that's under consideration for us, and we want to get to that at some point. So we actually applied our AIOps tool, Opni, to real K3s outages at Rancher Labs, and it ended up working really well. I think our support engineers looked into this for about a week and a half and pinpointed the logs that we see at the bottom right in their manual research, in their manual investigation. And Opni, in under 45 minutes, because it took around 30 minutes to train the model, in about 45 minutes was able to ingest all the data and look back in time and identify which logs were anomalous. And yeah, it would have saved our support engineers a week and a half worth of their time. Also, when we compare it for that same outage, when we compare it to the metrics that our support team was looking at, we see that, so the anomalous event, actually, the incident came in between 10:30 and 10:31, and we start seeing a bunch of spikes in the CPU, the network, disk I/O. We start seeing a spike in between 10:30 and 10:31. Those logs that indicated that those spikes were going to happen, that anomalous behavior actually happened at 10:29:50, just right before that mark. And if you look at the AIOps insights that I've kind of overlaid onto this screen, the Opni insights, Opni was able to catch those anomalous and suspicious logs before the metrics were able to capture this data. And so not only do you see a spike, Opni gives you the benefit of pinpointing which log messages contribute to this spike. So even if say network IO spikes, you don't know which services that impacted. And you may be able to, because Prometheus Datadog allows for this type of stuff. Like you can start looking into which pods and containers had the same network spike. But again, there's nothing that pinpoints the log messages, which tell a better story than metrics can.
I think this is really interesting. You are able to detect something before it actually happens, the anomalies. So that is pretty interesting. And that would, there are so many things that can, be prevented because of the insights from the Opni dashboard. So I think that can be real game changer for the support SRE teams if it is, used in a correct way. So that is really interesting.
Yep, exactly. And so right now we have just log anomaly detection, right? And that's only one piece of the puzzle. Very soon for v0.2, we're going to introduce metrics, metric anomaly detection. So already Rancher Monitoring installs Prometheus and Grafana for you. So we want Opni to be able to work seamlessly with that and have metric anomaly detection on top of it. And so you're going to have a similar dashboard to what you saw in Kibana for logs. You will have a similar dashboard in Grafana for metric anomaly detection. We also want to introduce Kubernetes events. We're going to have a custom UI to enable a bird's eye view using Opni log and metric insights. So basically get the best of both the Kibana dashboard for Opni as well as the Grafana metric anomaly dashboard, combine it into one single location. So that way that's your go-to for if you're trying to investigate an outage or you're trying to see what is the health of your Kubernetes cluster, you can see it all in one dashboard. We also plan on leveraging this dashboard to allow the user to give the Opni models feedback on how it's doing. So let's say you see that you see a particular log message that's being repeatedly marked as anomalous or suspicious, and you look at it and you say, hey, this is clearly not anomalous behavior to me. I want to tell the model, like, this is not a good prediction. So you can give prediction to the model, and its next retraining, it will understand, it will take your feedback into consideration and basically improve itself. So that's where you'll be able to have direct input into the models. Other ideas under consideration, audit logs, trace logs. There's a whole bunch of rich data that all these monitoring tools and observability tools are exposing. And so depending on what you guys as the community want, we're going to start looking into more of these different data sources. And so for what's out there already, we released v0.1.1 like a week and a half ago. It allows you to view Opni's logs, log anomaly insights in a demo environment created in a VM. So basically, the entire demo minus the workload anomaly portion of it. If you have a VM that is bare bones, and I'm going to show you guys in just a second, you'll be able to run this this demo. And v0.1.2, which is going to be very soon, it's going to allow you to full install Opni into your existing clusters and consume log insights from it. So before I continue, I'm going to quickly show where you can access the demo and start playing around with it. So if you go to opni.io, there's this one curl command. So if you have a VM with 8 CPUs, 16 gig RAM, go ahead and just that's all you need. Just spin up a VM like that, and what I actually have is a bare bones VM that I just created. So I'm just going to show you guys like what that looks like. So go into it. Log into root. And just one command install, and it's going to install everything for you. So since this is a bare bones VM, it's going to install an RKE2 cluster, a single node RKE2 cluster. It's going to install Opni into that cluster, as well as what all that comes with Opni. And before our talk started, I installed this exact same thing into another VM just to show you all what that would look like. And so after the one command install, after all this is done, it's going to tell you to navigate to this endpoint. So you would get your IPv4 address from AWS, whatever you're using. And so I have this guy right here. And the port that it exposes is also here. So this sets up Open Distro Elasticsearch Kibana for you. It automatically injects an error, fault injection error. So once you're here, explore on my own, hit global, go to the left-hand side, navigate to the dashboard, hit Opni Logs dashboard. Since I created this about an hour ago, let's just go to the last 90 minutes. And so, we automatically injected an anomaly initially for you. And so we are actually preparing a fault injections interactive script that will prompt you other fault injection scenarios that you can install into this demo environment to help you play around and understand, like, what is the capability of the pre-trained model, how it works. So if you go to our GitHub repository, you'll be able to see that some of basically all our progress and updates. And so one thing I want to really hone in on over here is you as the user have a bunch of different options for installing Opni. Right now for our v0.1.1, it's just a demo, right? And our next iteration, which is going to come out either this week or next week, it's going to be all of this. So right now it's just this right hand side branch, which is try Opni out, and it's going to be on a VM. And so again, these are all single curl command installs. And so this single curl command that I just demonstrated, it's using Opni CTL underneath the surface. And Opni CTL is the tool that's going to walk you through all these different user scenarios. So for example, let's say you want to install Opni CTL into your existing cluster, and you are already using Rancher. You might find it easy to install Opni through the Rancher UI. And so we have instructions for you in your Cluster Explorer. You can go and install Opni through the apps and marketplace. Okay, so you'll be able to do that in a very easy manner. Let's say you're not using Rancher server, no problem. You can obtain the Opni CTL binary from our release and use Opni CTL to install Opni and everything else. Let's say your cluster is already using Rancher logging or some other tool. Let's say you're already using FluentD to ship your logs over. No problem. We accommodate for that as well. So you as a user, we're going to accommodate for whatever setting that you have. So yeah, feel free to experiment, play around with Opni. All the updates, documentation is either going to be within this repository or on our website. So yeah, please check that out periodically and let us know within our Slack channel if you have any questions. Looking forward to engaging with you all.
So how for the previous demo, like you said, 16 CPU, sorry, 8 CPUs and 16 gigs of RAM. So where do we attach the GPUs then? So how this will take care of the GPUs? So if we have the VM with the GPUs, it should work automatically out of the box.
Yeah. So for the demo mode, it's not meant to be for GPUs, but if you already have an RK1 or 2 cluster and you do have a GPU attached, then what you would do is don't install it via demo mode. Instead, basically what I mean by that is don't run the curl command. Just use Opni CTL, have the guided installation, and then go ahead. If you have a GPU, then automatically it's going to start learning, right? If you don't have a GPU, you won't be able to leverage that particular model because it's not going to be able to train.
Cool.
Yeah, I mean just a small detail,
really
right? Yeah, just a small detail. Right now, we only support NVIDIA GPUs. We recommend that you use K80 or more powerful. Nothing less powerful than a K80 because it's a deep learning model. It's a fairly heavy deep learning model. So anything less than a K80, you'll see that it takes too long to inference and definitely too long to train. Yeah.
Cool. So I think people have loved that. So I think people are really interested. They love it. And you can see all the awesome comments that I'm just showing on the screen. So they're really, insightful metrics and basically insightful anomaly detection using Opni. And I think the deep learning models have excited the community as well. So that is really interesting. And yeah, I was actually very closely seeing the session, so it was really great to see Rancher going in this space, because this is an unexplored area of the logs, and if you can get the kind of detection from the logs, that would really be proved to be a game changer with the right set of deep learning models. And obviously the GPU thing will be there, like the models would get more insights when you have the GPUs, but still you are working on the CPU ones as well for the insights. Might not be as powerful as the GPU ones, but still it would work to some extent.
Exactly. And in the future, it's not only going to be logs, right? It's going to be metrics, and we're going to
Metrics.
introduce correlation between logs and metrics. So whatever operators are comfortable with right now using metrics, imagine in the future you're going to be able to see which logs correlate to the spikes that you see in your metrics. So that's kind of what we have planned out.
That would be really interesting to see. I mean, really looking forward to. I think we'll have a lot more streams on Opni, to be very honest, for each release, I think. Because there is something new that is getting planned for that. So yeah, also Sanjay touched on the community aspect already, which is very important. So I think the more we use it, the more we'll be able to tell what it does, what it does not do, and where and all we actually need the power from the anomaly detection. So all those things, if we can tell, so I think then the project would definitely go in the right direction. Obviously the Rancher team itself and the Suicide team, they have bunch of great folks who are doing that, but still the community can accelerate the development and all those. So definitely try that out. Yeah, if you have the NVIDIA GPUs, then probably use that. If not, then yeah, there are cloud providers that provide GPUs. You can make use of that. So I think that would really be interesting. And yeah, the Slack channel is there, Rancher Opni. You can go on the Rancher Slack and join that. I'm already a part of that, so definitely I'm going to try run this and ping on that channel if something doesn't work, because there are some GPUs that I can use. So definitely I would run that and see how things happen, what all things we can do. So that sounds really interesting. And thank you, Sanjay, for giving this session. And definitely I'll be keep talking with you more and more, because I'm super excited for this project and want to learn it, want to give you feedback, and help shape the project in any sort of contributions that I can do. So yeah, again, a lot of good comments. So, and thanks to the community for joining in. You people are awesome. Because of you only we get to understand, like you really have liked the product and you would want to use it, so which shows the interest level. So thank you all for joining in. And last but not the least, we have the swag giveaway. So we have around, this time we have a lot of responses, so we have 56 responses in the swag giveaway. So Sanjay, if you can pick any five random numbers, probably we can do the giveaways.
Okay.
Between 1 to just hold on, I'll tell you the exact count. Yeah, so 1 to 56, if you can give the number, then
Okay. How many do we need?
5.
5. All right. I'll just pick some Fibonacci numbers. Let's go with 5, 8, 13, 21, and 34.
5, 8, 13, 21, and 34. Okay, let me go here. So 5 is Rutam Prita Mishra, and I'll copy paste the name as well so that you people have the names. And next is 8. So 8 is Chanchal Bansal, and there's the name. Next is 13. 13 is Chandan Kumar, and this is the name. Next is 21, Saloni. Next is 34. 34, Ramesh Mishra. Awesome. So, thank you all for joining in, and congratulations to all the winner. I'll be giving your details that you have filled in the form to the society team, and they'll be collecting your mailing addresses and then sending you the swag out, which is the chameleon plushie. So great for tuning in. Obviously, you come for learning. You get some motivation. Obviously, some of you win some swag as well. We have to keep on doing this, and there's one more stream with the Rancher Super Stream series left, which is on Harvester. So make sure you join on 30th as well. So we have done Cube Warden, we have done Epinio, we have done Rancher Desktop and Kim. Now we have done today Opni, and we'll be doing Harvester as well. So I think Rancher and SUSE team are killing with all the open source products, solving specific problems, and Opni comes as kind of a new tool in a different direction, which there has not been much done in this particular space. So this is a very interesting area that the Rancher and SUSE folks have kind of explored and created something usable. So I'm really excited to see where the project will go, and will be definitely involved in the interactions with the Opni team. Definitely, and kudos to the team for building at least something usable for the community.
Cool. Thanks, Sam.
Thank you, Sanjay, and thank you all. See you all next time. Bye.
Bye.